Imagine you're locked in a room. The heavy door shuts, the bolt slides into place, and you have no context for why you're here. Then, a piece of paper slides under the gap. It's covered in intricate, unrecognizable Chinese characters. You find a massive English rulebook on a desk. You don't know the language, but the book tells you how to respond based purely on the shapes of the symbols. You match the shape of the input to a specific rule, which tells you to draw a different shape onto a new piece of paper and slide it back out. Over several hours, you get faster at looking up the rules. It becomes a rapid, mechanical loop. See a shape, find the rule, draw the new shape, pass it back. You have become a highly efficient symbol shuffling machine. Outside the room, the people sliding those papers under the door are native Chinese speakers. They are asking questions, and the papers you pass back are perfectly fluent, logical answers. To them, they are having a meaningful conversation with a conscious being inside the room. Yet, sitting at that desk, you still don't know a single word of Chinese. You don't know if you're discussing the weather or debating philosophy. You are completely blind to the meaning of the symbols you've been flawlessly manipulating. Flawless external behavior does not guarantee the presence of internal comprehension. Even if the output is indistinguishable from a human speaker, the process inside can be entirely hollow. This scenario is the Chinese room, a thought experiment proposed in 1980 by philosopher John Searle to challenge the very foundation of artificial intelligence. Searle was responding to the Turing test. Alan Turing had argued that if a machine's behavior is indistinguishable from a human's in a conversation, we should consider that machine intelligent. To dismantle that idea, Searle distinguished between syntax and semantics. Syntax refers to the formal rules and physical shapes of symbols. Semantics is the actual meaning, the connection between those symbols and the real world. When a digital computer runs a program, it operates exactly like the man in the room. It processes strings of code based entirely on their syntactic properties, without any awareness of what that code represents. From this, Searle argued that syntax by itself is neither constitutive of nor sufficient for semantics. Shuffling shapes does not create meaning. No matter how complex the programming becomes, a machine built on syntactic rules remains blind to the data it processes. It is simulating a mind, not being one. Today, we have effectively built a planetary-scale version of Searle's room. We call them large language models. This diagram shows the predictive engine of a modern language model. It uses advanced mathematics and statistical weights to calculate the next likely token in a sequence. It is linking empty, meaningless tokens together, based on the probability of their arrangement. The resulting outputs are convincing enough to write poetry, pass legal exams, and simulate empathy. But the underlying process remains a mathematical calculation of probabilities, not a grasp of concepts. The architecture of the room is now physical hardware. Those server racks are the walls. The training algorithms are the English rulebook, and the silicon processors are the man inside, matching inputs to outputs. We have increased the speed and scale, but the system still lacks an intrinsic connection to the physical reality it describes. It remains a manipulation of symbols without lived experience. This leaves us to wonder if these systems are genuinely understanding the world, or if we are simply witnessing a flawless simulation of understanding. Critics of Searle often point to the system's reply as the most significant counterargument to his thought experiment. This view argues that focusing on the man in the room is a mistake. While the man himself doesn't understand Chinese, the entire system, the man, the rulebook, and the memory banks, collectively understands it as a whole. Philosophers like Daniel Dennett describe understanding as an emergent property, a capacity that arises only when a massive network of simple, interacting parts begins working together. If understanding is simply what happens when a complex system processes information, then we have to point Searle's argument directly at human biology. Individual neurons don't speak English or possess consciousness. They simply shuffle chemicals and electrical impulses back and forth, following the blind biological rules of physics. On a micro level, the firing of human neurons is no different than the man shuffling papers inside the room. Both are components following a set of instructions without seeing the big picture. If we refuse to attribute understanding to an AI because its internal steps are just mechanical rule following, we have to consider if our own comprehension is built from those same blind pieces. If any system behaves exactly as if it understands the world, we may never be able to prove that it doesn't, leaving us trapped on the outside of every mind but our own.